All right, so we'll quickly go over here, scientific notation, and see how that goes. How do I turn my pen on there? So the basic idea here is pretty simple. You have to write really long numbers like, or something like that, and you get big long numbers. And you want to write these in a more concise way. It helps with writing numbers in a shorter way. Not really necessarily this one. I didn't pick the greatest example, but if there's zeros, you could drop at the end of it. Then this will help. And it also helps with doing math, which we'll explore later. It helps you with adding numbers and subtracting numbers and multiplying numbers together and dividing it if you need to do quick estimations in your head. So the basic idea is to put one number, your first number, and then a decimal, and then write all the rest of your numbers. You can leave off the zeros if they're not significant, which actually writing something in scientific notation is a good way to decide if numbers are significant. But then you have to multiply it by an amount equal to however many decimal places you moved over. If we look here, there's 3, 6, 7, 8 decimals. That means there are 8 powers of 10 I would have to multiply this by, so I can do 10 to the 8th, and I've got my number there. It's really simple. I'm pretty sure y'all are already good at this, especially since you complained that I was doing this, but whatever. There you go, you saw it. The real great help here is with things like addition. If I want to add big numbers or things like that, I can write them more concisely and not do stuff. So 1.2 times 10 to the third plus 2.6 times 10 to the third. I don't have to worry about this because if I wrote this all out, this would just be a bunch of zeros added to the end and it would all line up nicely. So I can just add 1.2 plus 2.6, and that's 3.8, and then I can just carry over all the zeros I had at the end, and it's 10 to the third. Pretty simple. But what if you had something like 1.2 times 10 to the third, and over here you had 2.6, and it wasn't actually 10 to the third? What if it was 10 to the second? At that point, your zeros don't line up. So you couldn't just make this 3.8. If you made it 3.8, it would be wrong because this digit and that digit wouldn't line up if you wrote all the zeros out and moved the decimal over. They wouldn't be the same order of magnitude there. So what you need to do is make sure these powers of 10 are the same. So this one can stay just 1.2 times 10 to the third, and we can change the other one. So we need to make this a times 10 to the third. So if we're going to basically multiply this 10 by another 10 to make it 10 to the third, well then in order to keep this number as the same number, we need to divide this number by 10. We basically took a 10 out of here and moved it over into there, so this becomes 0.26. In other words, we made this number bigger, we have to make this one smaller by the same factor of 10. And now we can add these together. This is 1 plus 0, the 0.2 and the 0.2, and we would get 1.46, and then times 10 to the third. So similar type thing for subtraction. You would just do that same sort of thing, but with a minus sign, and that would be fine. For multiplication and division, to multiply, you don't have to worry about making the factors of 10 the same. You just have to worry about multiplying these two numbers out in front and then adding the exponents that we have there. So we could have 1.2, I'll go with that number again, times 10 to the third, and this time we'll do times, this whole thing times, and we'll pick something a little easier. Let's do 3 times 10 to the 8th. Okay, so this is pretty simple. You could go and write this all out or type this whole thing out in your calculators and it'd be a big pain, or you can just multiply this first number here times this first number here. So 3 times 1.2, that would be 3.6. and then you have to basically multiply a 10 with 3 zeros, or a 1 with 3 zeros, and a 1 with 8 zeros together. And when you multiply things with lots of zeros, as you learned when you were young back in elementary school, you just add the zeros, which means we add the exponents 10 to the 11th. And we're done. Super simple. We didn't have to use a calculator or do anything like that. Had this been division, it would have been similar, but sometimes you might have to move it around a little bit. So 1.2 times 10 to the third now divided by 3 times 10 to the eighth. And you look at this and you're like, well, that's kind of difficult. We have a bigger number in the denominator and a smaller number up here, even in the orders of magnitude here. So what we can do is make this into a number that's pretty easy to divide. 1.2 divided by 3, maybe not so easy to see, but what about 12 divided by 3? That's pretty easy to do right there. So we can change this, just like we did up here. We can add a 10 onto here, but if we multiply this by 10, we have to divide this by 10 to make it still the same number. So this is 10 to the second, and this is 3 times 10 to the 8th if we leave it alone. And now it's pretty simple to do. We have 12 divided by 3, which is simply 4. And now we have to worry about our powers, our little powers of 10 here, our order of magnitude. We have 10 to the second divided by 10 to the 8th. And here, you don't divide 2 by 8 or anything like that. You don't add them. You actually subtract 2 minus 8. And this will become 10 to the negative 6. Okay? And so that's multiplication, that's division, that's addition. And it's pretty simple if you follow it after that. I know it seems almost a little counterintuitive, I see, for a lot of students. But ultimately, your life will be easier. Okay? Avoid using those calculators.